matter if you've got, let's see, a over b. Let's do it this way: a over c, b over d. Right? If you're doing this, you can write it like this, and that's completely okay because multiplication is associative. I can prove it to you. When you're multiplying fractions, right, you're going to end up multiplying from left to right. Same thing. You realize how this is the same? Pause the video if you need to. All right, moving on. Okay, so let's say that, and here's the first three sets of our rules. Let's say that you've been given, let's say n equals 2, m equals 3. So we're going to do the exponent multiplying rule, right? We're just using that distributive property to get n times m. So let's go ahead and do this. For this, we're going to have x to the second power times 3. That's going to give us x to the sixth power. So for this one, when you have parentheses, and you can always invoke your parentheses, you're just simply multiplying the exponents, right? But for this one, right,
Right. Brett and I, we think we ought to.
You're just adding your exponents together, right? So you've got n equals 2, m equals 3. We use our rule. That's going to be x to the n plus m. That stays up there. Whenever you're working with exponents, that's just the way it works. We're really doing a lot of the math on the exponents here. If you focus on that, it'll help you out greatly. So this is going to be equal to x to the fifth power. Again, I'm going to discuss why that is abstractly, as I typically do in my videos. If we just simply use this rule, right, it's going to give you x to the n minus m. We're going to have 2 minus 3. That's going to give me x to the negative 1 power, right? So just kind of rewriting what we did here. Anytime you have a negative exponent, some teachers may let you keep it, but typically it really doesn't matter what you do because we know that that's going to be 1 over x, right? X to the first power. So it's going to give you 1 over x to the first power. Anything, x to the first power is just going to be 1 over x. So there that is. Now, I promised I would explain why this works the way that it does. So if we look over here at the x squared and x3, well, let me just write this out as if we had two x's in here, right? Is I want to kind of use maybe a variable that y'all are, let's try to simplify this. Let's just say we have p cubed, right? We know that's going to be p times p times p, right? So I want you to kind of make believe that these two x's multiplied together give you x squared. That's just going to be kind of like our p there. So then if we do this, then what I can do is I can simply just write this out as x. That's not 6 times x. There are no coefficients in these problems unless they've been given. And another way to see this, and the way I really kind of like to explain this now that this has been really kind of layered out here, is that this is just going to give us x to the 6, because we know we have 6 each have a power of 1. You've got 6 x's. Let's make that simple. What if you had something like x cubed, right? For cubing something, you're finding the volume, right? It's the same thing when we're talking about exponents, right? All with the same side lengths, going to be equal to x times x times x. Volume is equal to x cubed, right? I just like to provide like an example with something that you're familiar with on a daily basis so that you can understand this idea, right? So when you're doing things like this, another, like a basic example, let's just do x squared times x squared, right? Well, 2x squareds. We're multiplying x squared and x squared. That's going to be x to the fourth power. Let's try something different. What if you had x, um, again, this proves that you've got x2 plus 2, right? Let's try something else. What if you had the area x squared, right? And you're like, okay, what if I want a cube? Okay, x to the first power. Oh, look, there's that rule. right? So let's do the problem. Up above, we've got x, let's see, 3, 2, right. Just like the ABCD problem, it doesn't matter which ones you put over what. Multiplication and division is associative. So we're just going to go ahead and write this as x3, x2, and then times y4, y3, right? So why does it work? Well, I'm going to go another direction here, right? Let's say that we had instead, we're just going to go all the way across and evaluate this two different methods, like one you might do, right? So, which wouldn't be wrong. So what we're doing here is we're just compartmentalizing. I want my x's together and my y's together. Well, you can do this. You can do it for as many variables as you want to do. It's completely legit, and I'm going to show you why. So right here, skipping that step right there where I grouped it, and you can see how it's the same problem. Just because they're multiplied on paper one way or the other, it's still the same thing. Multiplication is associative. It doesn't matter where you put it. It's not geometry, it's algebra. So we can go ahead and do that if we want to, and that works. So now let's say that instead, now that you know this, we're going to go the grouping route, or not grouping, sorry, compartmentalizing, that's what I'm going to call it here. We're adding, subtracting the exponents. So that's that one, and that's why I compartmentalize them. For this reason right here. Now you can visualize it, that's fine. You can go straight in there, and you've got x to the first, y to the first, no big deal. And here's the reason why for that, right? We're just going to do the math. That's going to be x to the first power, 3 minus 2 is 1, and then y to the first power, that does in fact give me not two separate problems. I'm just really breaking it down for y'all. All right, so hopefully that helps. In the next video, we'll start working through some problems.
Coming! Let me coming!